All right, let's look at this example that is a little bit different than the previous ones. All right, so we have of the men age 65 and over, 20.5% are still in the U.S. labor force. Now we are looking at a random sample of 120 retired male teachers that indicated that 38 were still working. They're asking us to use both a confidence interval and a hypothesis test, and they ask us to test the claim that the proportion is greater than 20.5% at alpha equals 10%. So first of all and foremost, let's decide, guys, what kind of test or what kind of a confidence interval we are doing here. And that is going to be driven for us by the type of the question. Okay, so what kind of a question are we asking here? What is the parameter is the center of the question? And it says here, test the claim that the proportion is greater. So it seems that our parameter here is a proportion. Otherwise, it could also be mean or variance or standard deviation, okay? Those characteristics of the population that we are sort of hypothesizing about. Okay, so since our parameter is proportion, we are going to be also doing a confidence interval and also a hypothesis test for this proportion. Now, proportions don't have a lot of options, okay? This is not mean where you need to ask yourself additional questions. Proportions only work with z-tests and z-intervals. So we're going to have a z-interval and a z-test here, not too many options. So I'm asking you here, really briefly, state your hypothesis. Let's start with the hypothesis, and then in the second part, I'll do the confidence interval. All right, so hopefully you did that. So my no is P is 20.5%. Okay, and then the alternative seems to be that it is greater. Okay, that it is greater. That's my claim. Now, P and not P hat, be careful. P hat is not a parameter. That's a statistic. You don't need to hypothesize about statistics. You just count them. All right, and this one is greater than 20.5%. And this over here is my claim, and my alpha is 10%. So this is a one-tail test at alpha equals 10%. And this business over here is 10%. Okay, now that I have everything set up, I know what proportion it is, what parameter it is, which is proportion. Now I'm going to go and calculate my z-test statistic. Feel free to pause here and do your z-test statistic on your own, and then compare it with me. All right, so my z-test statistic in this case, before I can go ahead and calculate that, first of all, I need my p-hat. In order to calculate the p-hat, I'm going to do 38 out of 120. Okay, and that turns out to be, okay, this one over here turns out for us to be 0.316. Okay, so this is my p-hat, or this is my observed value. So 0.316 minus the hypothesized value, 0.205, okay, 20.5%. And then don't forget that when you're doing this business over here, we are going to use the p-hat, the p and the q, not the p-hat and not the q-hat. All right, so this one over here is going to be 0.205 times what is that? 795, right? Over 120. Okay, so this whole entire thing is going to be inside the square root, and that's the difference. And also, when we are doing a hypothesis test, we are using the hypothesized value because that's the p rather than the p-hat. If you didn't have the p, you'd use the p-hat. All right, I end up here with 0.30. I'm sorry, I'm ending up here with 3.011. Okay, so this is a pretty steep value. Okay, and especially that my alpha is 10%, this is pretty out there. So this seems to be that this proportion is greater. Now, if you want to figure out your p-value, just go and figure out how much is, you can use a calculator or one of the online apps. What is the probability of Z being 3.01 in that context? So the probability here is essentially going to be greater than, and then 3.01. And we end up with a fairly small p-value, 0.001. Okay, as the probability is the p-value is smaller than your alpha, we are good to go and reject our null. Okay, we're rejecting our null, and as our claim was on the alternative, we can say that we have sufficient evidence to support the claim. Alrighty, in the next video, I'll do a quick confidence interval for the same proportion of working males over the age of 65.